Law of cosines, side angle side, side side side, and angle side side. When you're given information like this without a triangle, I suggest first that you draw just an equilateral triangle that's not to scale and put the information that you're given, and then use that not to scale triangle to make one that is to scale. So here's one that's to scale. The convention is that you use capital letters to represent vertices and the corresponding small letter, lowercase, to represent the length of the side opposite it. Same here with B and C. We're asked to find, in this case, small c. Now the only angle that we know or want to know is capital C. So I always focus at the end. It's always the cosine of the angle that's known or that you want to know. This is capital C, then we're going to have to start with small c up here. And then we're going to write essentially the Pythagorean theorem, c squared equals a squared plus b squared. And then minus 2ab, ab, ab. So we can now make the substitutions of A, B, and capital C. This so far is c squared. If you take the square root of both sides, you get what c is equal to. That's what it's equal to. And then if you go put that in your calculator, you'll get what it's approximately equal to. And that's in degrees. That's the length of the side, rather. And here you can see that if this is 42, because this is drawn to scale, it seems to make sense that this is about 53, a length of 53. Now let's move to side, side, side. Again, try to draw it to scale. Now, angle F is the only angle that we want to know. We aren't given any angles, and we want to know angle F. So again, put the angle here, capital F here, which brings us back to small f squared equals d squared plus e squared. dE is here, minus 2dE. That gives us the structure. We make all the substitutions that we know, which are the lengths of F, D, and E. And we can evaluate this and get it into one number, and this and get it into one number. And then from here, you want to do the following. First, you're going to subtract this from both sides. Then you're going to divide this into both sides, and then take the inverse cosine. So you're going to undo from left to right. Subtract, divide, inverse cosine. So we subtract 2,125 from both sides. Now we're going to divide negative 1,596 into both sides. And then we have to take the inverse cosine. So capital F is equal to the inverse cosine of this ratio, which is approximately equal to 115.4 degrees. If you look here, that seems to make sense. Angle side side for law of cosines involves the quadratic formula, and we'll also learn how to do this with the law of sine. So you'll have two opportunities if you have an angle side side problem. So if you're given an angle side side problem, the reason why I write it ASS is because that's the order that you want to draw when you're trying to draw to scale. First, note I draw an angle, and I'm just drawing the rays. Then I draw one of the sides and arbitrarily stop someplace, which now determines the scale for the picture. And so this is angle side, and then this other side. But if you think of using a compass that would be put its point down here and swing along down here, this second side could go from here to here, or also from here down to here. So it gives two triangles, which we often call the ambiguous case. If we substitute the values that we have into the law of cosines, it's the only angle that we have, capital Y, which brings us back to small y squared over there, and make our substitutions, we have a quadratic in x squared x. And if we rewrite this as a quadratic in x set equal to 0, we can put that in the quadratic formula, which gives us that. And if you evaluate, you get two values for small x that we're trying to find, the length of this side. 44.1 is the short side with this triangle, and then you can move to the other triangle, the larger triangle, which would give x a side of 55.5 approximately. Again, this is what it's equal to, and these are the approximations.